Hello everyone, my name is Mohammed Ziyaul from second year EC department. Today I want to discuss about the topic elements of communication system. What is communication? Communication is a process of establishing a connection or link between two or more points for the exchange of information. Analog communication had a significant need for centuries as it has been a fundamental need of human interaction which allows anyone with the continuous transfer of signal along with the information. Let's explore the basic principle, essential terminologies, application, advantage, and limitations of analog communication in this article. Whoever wants to understand how this communication system work, then it is required first understand the fundamental of analog communication, as we have seen a vast development of digital communication. Still, analog communication are very beneficial in almost every sector as everything around us is in analog form, including television, radio, broadcasting equipment, and telecommunication. Now, the elements of communication system. Input transducer. The input transducer convert the information in the message signal into the electrical energy suitable for transmission. The sources of information are audio, television, computers, etc. The frequency range of each signal is from 300 Hz to 3000 Hz. The frequency of video signal is 4.2 MHz. The frequency range of television is 0 Hz to 6000 kHz. The output of the input transducer is fed to the transmitter. There come the transmitter. The transmitter converts the electrical signal into a form suitable for transmission for the channel. It performs modulation by superimposing the message signal on the high frequency carrier signal. Thus, the different channels have different types of transmitter. If the channel's characteristic varies, the transmitter must adjust itself to maintain the desired range for the effective communication. The original signal is known as the message signal or the baseband signal. The transmitter also performs multiplexing, that is simultaneous transmission of several signals. Next one, the communication channel. The communication channel is a medium to transmit the electrical signal from transmitter to the receiver. The communication can be broadcast or point to point. Broadcast refers to a single sender and multiple receiver, such as radio. Point-to-point communication refers to the communication between a single sender and a single receiver, such as a telephone. The essential parameter for suitable transmission is bandwidth. The greater the bandwidth, better will be the transmission. The communication channel is further categorized as wired channel and wireless channel. Wired channel. The example of wired channel are twisted pair cables, waveguides, cables, and optical fiber. Twisted pair cables. These are the two conducting cable twisted to improve the transmission ability. The twist in the two conductor couples the electric or magnetic fields and prevent the noise interference in the channel. It is commonly used for wired shielding, prevent the data from the external noise. Waveguides. The waveguides can transmit the electromagnetic wave without any energy loss or minimal loss. It is commonly used in radar and microwave communication. Optical fiber. An optical fiber is a transmission fiber made up of plastic or glass. It can transmit the data up to 100 or kilometers without affecting the signal quality. The transmission is based on TIR, total internal reflection. The diameter of the fiber is as small as a human hair. Wireless channel. It is the communication in the form of EM, electromagnetic wave, from one antenna to the another in space. The transmission depends on the frequency of EM waves. Now the interference factors. The interference in the channel is termed as noise and attenuation. Attenuation is defined as a loss in the strength of signal. It is also known as distortion. The attenuation is caused by the passive component in the communication system, such as cable and connectors. It is low in optical fiber as compared to the other type of media. Noise is a serious factor in the communication system. It is defined as any unwanted interference in the signal during the transmission. Noise is characterized as internal noise and the external noise. Internal noise. The interference that occurs during the signal transmission inside the communication system is known as internal noise. Example of internal noise are thermal noise, short noise, etc. Internal noise can also arise from the recombination of the carriers, electrons and holes. Now the external noise. The interference that occur outside the communication system is known as external noise. The example of external noise are lightning, ignition, electrical switching, etc. Receiver. The receiver receives information from the channel. It extracts the necessary information from the signal required by the output transducer. The receiver performs the opposite of the modulation and multiplexing, that is demodulation and demultiplexing. It also amplifies and removes noise from the signal. Now, the output transducer. The output transducer works reversely that of input transducer. It converts the electrical energy into the original signal. We can also say that it makes the information available, understandable to the target. Example of output transducer are loudspeaker, motor, LEDs, etc. Both the input and the output transducer are important because they convert the suitable signal from the transmitter and increase the signal speed. The loudspeaker convert electrical energy to sound energy. The motor convert the electrical energy into a motion. The LEDs, light emitting diode, convert the electrical energy to the light energy. Some channels also use amplifiers or filter to remove the noise or distortion from the signal. Noise present in the signal can affect the signal quality. Hence, it is essential to use such component in the circuits. Now, the types of signals. The signals are of two types, analog or continuous signal, and the second one is digital signal. What is analog or continuous signal? It is if the amplitude of signal continuously varies with respect to time, or if the signal contain infinite number of amplitude, then it is called an analog continuous signal. What is digital signal? If a signal contain only two discrete amplitude, then it is called digital signal. With respect to communication, signal are classified into baseband signal and bandpass signal. The baseband signals. If the signal contains zero frequency or near to zero frequency, it is called a baseband signal. Example, voice, audio, video, biomedical signal, etc. Bandpass signal. If the signal contains a band of frequency far away from the base or zero, then it is called a bandpass signal. Example, AM, FM signals. Limitation of communication system. First one is technology problem. To implement communication system, TX and RX channel are required, which require hardware communication system is expensive and complex. Bandwidth and noise. The effect of noise can reduce by providing more bandwidth to the station, but due to this less number of stations can only be accommodated. Signal to noise ratio SNR. Noise should be low to increase channel capacity, but it is unavoidable aspect of communication system. Now the topic is modulation. Modulation is defined as the process of superimposing a low frequency signal on a high frequency carrier signal, or the process of varying the RF carrier wave in accordance with the information in a low frequency signal. To invert data information or speech information, another wave has to be imposed, known as the input signal, above the carrier wave. This process of imposing an input signal on a carrier wave is known as modulation. But differently, modulation modifies the shape of a carrier wave to encode the data information that we intended on carrying. Modulation is similar to hiding code in a carrier wave. There are three types of modulation, namely frequency modulation, amplitude modulation, and the phase modulation. Now, what is amplitude modulation? It is a kind of modulation where the amplitude of the carrier signal is changed in proportion to the message signal while the phase and the frequency are kept constant. Now, the phase modulation. In this type of modulation, the phase of the carrier signal is altered according to the low frequency of the message signal, and hence it is called the phase modulation. Frequency modulation. In this modulation, the frequency of carrier signal is altered in the proportional to the message signal while the phase and the amplitude are kept constant. Is called frequency modulation. Now, what is the need for modulation? First one is the practical length of antenna. For the effective transmission of a signal, the height h of the antenna should be comparable to the wavelength lambda of the signal. At least the height of the antenna h should be lambda by 4 in length so that the antenna can sense the variation of the signal properly. The low frequency message signal has a very high value of lambda, which will require a very high antenna. That is practically not possible. Second one is the narrow banding of signal. An audio signal usually has a frequency range 20 Hz to 20 kHz. If it is directly transmitted, then the ratio of the highest to the lowest frequency become 20 kHz by 20 equals to 1000. But if this audio signal is modulated over a carrier signal of frequency 1000 kHz, then the ratio of the highest to the lowest frequency become 1.2. Hence, we need a modulation to convert a wideband signal into a narrowband signal. The third one is the frequency multiplexing. It is practically not possible to distinguish between the different audio signal when transmitted simultaneously through a single antenna, as all of them lie in a same spectral range. Hence, each of these signal is translated to a low frequency range before transmission, which makes it quite easier to recover them and distinguish each of them from one to another at the receiver's end. Thank you.